Hello, everyone, and welcome back to the Tony Livins podcast. I am Tony Livins. In our last episode, we explored deep learning and neural networks, the technology that transformed artificial intelligence and made many of today's breakthroughs possible. But today, we are going one step further. We are going to answer one of the questions I hear all the time. How does ChatGPT actually work? Not the headlines, not the hype, the actual technology behind it. Because when people use systems like ChatGPT, Gemini, or other AI assistants, they often say something like, it feels like it's thinking, it understands me, it sounds human. And honestly, I understand why people think that. The responses are incredibly natural. Sometimes they feel almost conversational. But beneath that smooth conversation is something called a large language model or an LLM. And today we are going to break down exactly what that means. Let's start with the word language. Humans communicate through language. We use words to express ideas. We ask questions. We tell stories. We explain complicated concepts. Language is one of the humanity's greatest inventions. But for a computer, language is just data. Words are converted into numbers. Sentences become mathematical representations. The AI doesn't see English, it doesn't see French, it doesn't even see words the way we do. It sees patterns, relationships, probabilities. Now let's talk about the word large. Why do we call it a large language model? Because these systems are trained on enormous amounts of text, books, research papers, websites, articles, computer code, public discussions, educational material, billions and billions of words. The goal isn't to memorize everything. The goal is to learn how language is structured, how ideas connect, how people usually communicate. Now, here's something that surprises most people. An LLM isn't trying to understand what you're saying, it's trying to predict what comes next. That might sound disappointing, but it's actually incredible. Imagine I start a sentence, the capital of France is. Most of you immediately think Paris. Why? Because you've seen that pattern before. Large language models work in a similar way. Except instead of learning from thousands of examples, they learn from billions. Every response is essentially a prediction. What word is most likely to come next? Then, what word comes after that? And then again and again until an entire paragraph appears. Now, here's another concept that's important: tokens. People often think AI reads one word at a time. Not exactly. Large language models break text into smaller units called tokens. A token might be a whole word, part of a word, a punctuation mark, or even a space. The model predicts one token at a time, very quickly, thousands of times during a conversation. When you ask a question, the model isn't generating the entire answer instantly. It's building it piece by piece, almost like completing an enormous puzzle. Now let's talk about something called context. Imagine you walk into the middle of a conversation. Without hearing what came before, you probably be confused. AI was the same way. The model needs context. Everything you written during the conversation helps the model decide what to say next. That's why sometimes if conversation become extremely long, the AI begins forgetting earlier parts. Not because it has memory like humans, but because there's a limit to how much context it can process at one time. This is called the context window. As technology improves, these context windows continue getting larger, allowing longer and more coherent conversations. Now let's discuss something called hallucination. This is one of the biggest weaknesses of large language models. Sometimes the AI produces information that sounds completely convincing, but is actually incorrect. It might invent references, create fake quotations, or confidently state something that simply isn't true. Why does this happen? Because the model isn't checking facts in the way humans imagine. It's predicting language. Sometimes the statistically likely answer happens to be wrong. That's why critical thinking is still essential. AI should support thinking, not replace it. Now let's compare AI memory with human memory. Humans remember experiences, conversations, emotions, personal moments. AI doesn't. It doesn't remember your childhood. It doesn't remember how it felt yesterday because it doesn't have experiences. It has parameters, mathematical values learned during training. These parameters allow it to generate responses, but they are fundamentally different from human memory. Now let's talk about training. Training a large language model is one of the most expensive computing tasks humans have ever attempted. Thousands of powerful graphics processors work together, sometimes for weeks, sometimes for months, processing unimaginable amounts of information. Every training cycle adjusts billions of mathematical parameters, tiny adjustments, repeated again and again, until the model becomes increasingly capable of predicting language. That's why only a small number of organizations currently have the resources to train the largest models from scratch. But training isn't the end. There's also something called fine tuning. Think of training as giving someone a university education. Fine tuning is giving them a specialized career. A model might first learn generalized language, then later be fine tuned for medicine, law, finance, programming, or scientific research. Same foundation, different expertise. Another important concept is retrieval augmented generations, often shortened to RAG. Instead of relying only on what the model learned during training, RAG allows the AI to retrieve fresh information from trusted documents or databases before answering. This makes responses more accurate, more up to date, and more reliable. Many modern enterprises AI systems now use this approach. Now everyone let's ask the question everyone eventually asks. Does a large language model actually understand language? In my opinion, not in the human sense. It models language extraordinarily well. It predicts language extraordinarily well too. But prediction and understanding are not the same thing. When you say the word ocean, you might remember the smell of the sea, the sound waves, a holiday, a childhood memory. The AI has none of these experiences. It knows statistical relationships. Humans know lived reality. There is a profound difference. So, why does it feel so intelligent? Because language is one of the strongest signals of intelligence. When something communicates fluently, we naturally assume understanding. But fluency isn't proof of consciousness, it's proof of sophisticated language modeling. And that's an important distinction. Large language models represent one of the greatest engineering achievements in history. They have transformed education, research, programming, healthcare, creativity, business, and communication. But they are still tools, powerful tools, remarkable tools, but tools nonetheless. The responsibility remains with us to ask questions, to verify information, to think critically, and to use AI wisely. As AI continues evolving, the real challenge may not be building more intelligent systems or machines. It may be ensuring that humans continue developing wisdom alongside them, because knowledge can be generated instantly. Wisdom cannot. Thank you for listening to the episode 10 of the Tony Levins podcast. If you enjoyed this episode, subscribe, share it with someone interested in artificial intelligence, and joined for episode 11. I'll see you in the next episode. Take care.